back. This is A-Level Computer Science 9618 paper 3. This is chapter operating system and this is part 3, and in this video we are going to understand about scheduling algorithms. There are 4 types of scheduling algorithms. There are round robin, first come first serve, SJF, SRTF. Okay. Round robin is also non-preemptive. What is meant by preemptive? Non-preemptive means that whenever the process come into the execution, so it will not be interrupted by any interrupt, it will not be interrupted by any process, and it will just keep on completing, it will keep on running until it has completed its burst time. For example, let's discuss about round robin. For example, this is round robin. This is our table. We got the process 1, process 2, process 3. We got the burst time. Burst time means that the time the process is taking from the CPU to complete its execution. Arrival time is when the process came into the execution part, the running part. So the time quantum is 4. This is what round robin is. You are giving us a fixed time slot for each process, and when that time slot runs out, another process comes in. Okay. So even though whenever, for example, we have different arrival times, so when the first for example the arrival time was 1, we got 4, we got 5. Arrival time was 1, P1 came first, so P1 will be executed first. Okay, like that. But since all of them are arriving at the same time, so I can just choose any one of them. Let's start from P1. Okay. So I have just taken P1 and I have just given 4 times slot to execute it, and after completing this, another process will come, P1 will come out. So let's suppose P2 came. It doesn't matter, because since both of them have it doesn't matter because three of them have the same arrival time. So any one of them came, P2 for example came 4 to 7, then P2 came out, or actually P2 is already executed. Then P3 came, P3 is executed, and then remaining is P1, 10 to 14, 14 to 8, 18 to 22, 20 to 26, 26 to 30. So this is round robin. Okay. You will be asked 2 things whenever you will be dealing with scheduling algorithm. You will be asked about turnaround time, and you will be asked about average waiting time. Turnaround time is the time to execute a particular process. So turnaround time is equal to completion time minus arrival time. Completion time means that the time it took for the process to complete its execution. Arrival time means that when did the process came into the running process, in the running state. Waiting time, you will also going to be asked about the waiting time as well. So after calculating the turnaround time, you can just put in here and then minus burst time. Burst time I have already told you, and just subtract it and you will get waiting time. Average waiting time means the number of, adding up all the waiting time of the process and then divide by number of process. Let's start from, okay, so we already discussed about round robin. Let's come to first come first served. Okay, first come first serve means first come first serve. So we are actually focusing on the arrival time. Any process which came first, which came early, it will be served first. So first come first served. So arrival time is 0 for process 1, 2 for process 2, 3 for process 3, and they have their respective burst time. So P1 came first, so P1 will be executed first, and it will complete its execution. It will completely use its burst time, because it is non-preemptive, it cannot be disturbed, it cannot be interrupted, it is doing its job, it's very important job, no one can disturb this, no one can disturb this guy. So process 1 is executed first. Okay, so 0 to 10, and while it was executing it, process 2 and process 3 came, because their arrival time was 2 seconds, 3 seconds. Okay, so during these times, process 2, process 3 came, process 2 came first, so process 2 will be executed first. So process 2 came, its burst time is 2 seconds, and then process 3 came, its burst time is 3 seconds. After doing so, then let's suppose I want to calculate the turnaround time. The completion time for P1 is 10 because it took 10 seconds to complete its execution. 10. Its arrival time, we'll discuss that later. The completion time for P2 is 12 seconds. The completion time for P3 is 15 seconds. Then let's suppose I want to calculate the turnaround time. After knowing the completion time for each of these processes, I know the respective arrival time from this given table. Now I'll just going to calculate this right away. So 10 minus 0, it will remain 10. 12 minus 2, it will be 10. 15 minus 3, it will be 12, and then divide by 3 to calculate the average turnaround time. So it will be 10.6. Now I want to calculate the average waiting time. So in order to do that, I need to know the turnaround time and the burst time. We already know that. Turnaround time is calculated from here. This is the turnaround time from each of these process. Burst time can be accessed from here. Now 10 minus 10, 0. Then for process 2, 10 minus 2 is 8. Process 3, 12 minus 3 is 9, and then you just divide by 3 after adding them, adding them, and then divide by 3, and then you will just get average waiting time. So this is first come first served. Now in the third scheduling algorithm, we got SJF, non-preemptive, and this algorithm, these two are the same thing, except it's this one is non-preemptive, this is preemptive. SJF, short job, something like that, shortest job for scheduling. This will be focusing on the burst time, that the least burst time of the process will be chosen first. Okay, the process requiring the least CPU time is executed first. We have the given table. We got the arrival time, the burst time, the process P1, P2, P3, P4, P5. So the lowest is 2, so this will come first, but since it didn't arrive yet, it started from here. Right now P4 came first. Okay, its burst time is 3 for now, so P4 will come and it will completely execute this because it said it is non-preemptive. So 0 to 3, and then during these 3 seconds, P3 and P1 came, P3 and P1, and now we're going to compare these two, that we know which one of them has the least burst time. P1 contains 6, P3 contains 8, so P1 will be chosen. It will come, it will execute, and during these time P3 and P5 came. We're going, and also actually P3 was already there, P5 and P2 came. Compare all of them. P2 has a least burst time, it will come, it will execute. Then compare them. P5 has the least burst time, it will come, it will execute, and P3 was the last one, it will come and it will execute. Now I want to know the total arrival time. So first finding the completion time. So the completion time for P1 is 9 seconds minus arrival time. Arrival time is 2 seconds. Let me just remove this because it is wrong. Now P1 is equal to 9 minus you got arrival time is 2. 9 minus 2. Then you are moving forward. For P2 is 11, completion time is 11, it took 11 seconds to complete this process. 11 minus the arrival time is 5 seconds, so 5 plus. Now we are coming to P3. It took 23 seconds to complete this process. 23 and minus, so 1. 23 minus 1. Okay, then we got P4. P4 took 3 seconds to complete this process. It will be 3. Okay, arrival time was 1 is 1. It is 1. So it is 3 minus 1. Okay, and so for 5 is, it took 15 seconds to complete this execution. 15 minus arrival time is 4. Okay, so P4 arrival time is 0 actually. So I just made a mistake in here. It is 0 minus 0. Okay, 15 minus 4. 15 minus 4. Now let me just check this. So P1, 9 minus 2. P2 is 11 minus 5. P3 is 23 minus 1. 23 minus 1. P4 is 3 minus 0. And P5 is 15 minus 4. All complete. And then at the end, after adding them, you will just divide this by 5 to calculate the average turnaround time. Now finding the average waiting time. So for P1 is 7. You got the total, the turnaround time is already calculated. 7 minus the burst time. Okay, so the burst time is 6 plus P2 is it is actually 6. Yes, 6 minus burst time is 2. Okay, P3 I got 22 and the burst time is 8. P4 3 and the burst time is 3. Yeah, P4 3 and the burst time is also 3. That's why it is 0. That's why I haven't wrote it down. P5 15. I mean, this is 11. 11 minus the burst time is 4. 11 minus 4. Okay, so this I've already calculated this, and then you just divide this by 5 and you have found the average waiting time of this as well. So this is your SJF. Now the most difficult part is this one, SRTF, preemptive part. Is this one is quite tricky, very tricky. So this is the last one, so let's begin. You got this table: priority, arrival time, burst time. Now what you are going to do, okay, so SRTF is preemptive, shortest remaining time for scheduling. The process are placed in the ready queue as they arrive, but when the process with a shorter burst time arrive, the existing process is removed, and from execution the shorter process is then executed first. So again we are seeing the shorter burst time, and having the highest priority. So the least having the least burst time is the highest priority. So supposing P4 came first, and during when P4 was executed, P3 also came. Then we're going to compare it. P4 was executing to P1. P3 came after 1 second, 8. So P4 was still having the least burst time. It keeps on continuing, and after 2 second burst times, this one came. But again, this one, P4 and P1 was compared. P4 again having the least burst time. It will keep on resuming its execution, and then eventually it has completed its execution. Then we're going to compare which one of them has the least one. P1 has the least one. P1 will come, it will continue. Then okay, so it continued for 1 second, because after 4 seconds P5 came, and P5 having the least burst time than P1, because after 1 second 6 become 5, 4 and 5, so 4 having the least burst time, so P5 will come after 1 second, P1 will drop out. So P5 came, and then we are comparing all of this. Okay, P1 having 5, okay, P3 is 8, and after 5 seconds P2 came, and having the least burst time too. After 1 second P5 having 3, 2, 3, so P2 having the least burst time, so P2 will come, and this will keep on going like this. So after executing this completely, it is executed. After this, P5 will come while it is executing. Okay, so this is 3, 7, 8, 9, 10. Yeah, completed its execution. P5, P1 will come, completed execution. P3 will come, completed execution. So this is how it's working. You will have to see each and every second that how much burst time it has left and how much that which process has came. Like for example, during these 3 seconds, P1, first of all P4 was executed. After 1 second P3 came. You will compare this. It if P1 having the least burst time, it will then just come in and P4 will drop out. This one will interrupt this, okay, because having the least burst time. But since it has having the greatest burst time, it will keep on continuing. Okay. Then after 2 seconds P1 came, comparing all of these. Still P4 is having the least burst time, because after 2 seconds the burst time becomes 1 and comparing with 3 and comparing with P1. So this having the least burst time, it will execute it completely. Then P1 came, because having the least burst time, it will came. And during these, after 1 second, P5 came, and then just going to compare this, like 5, P1 burst time becomes 5, P3 having 8, P5 having 4, so 5, 4, 4. So this will come after 1 second. P1, okay, so which one of the P2 came, okay. After 1 second P2 came, and P2 having the 2 second burst time, P1 having 5, P5 having 3, and P3 having 8. So 2 versus 3, so 2 is having the least. So this is how it's working, okay. This is how it's working. So average waiting time, this is exactly the same thing for each and every scheduling algorithm. That's exact same formula, calculating the turnaround time and then putting the turnaround time for each process, and then calculating the average waiting time. So this is how you could be asked in the paper. uh, like you could be given the table and you will be asked about finding the average waiting time and the turnaround time and something like that. You could also be asked for finding the difference between all of these scheduling algorithm. Round robin contains the, it will just give a time allocation of, it will give a time quantum for each process, a time slot for each process, okay. First come first serve means first come first served. It's focusing on the arrival time. SJF, shortest job first, shortest job first scheduling, okay. And SJF, okay, it is non-preemptive, it is focusing on the least burst time. This one is also focusing on the least burst time. SRTF, shortest remaining time for scheduling, okay. Both of them are the same thing. The only difference here is this is preemptive, this is non-preemptive. So these are the 4 scheduling algorithm, and this part 3 is finally completed. The operating system chapter is finally completed. Thank you so much for watching, and I'll see you guys in the next video, and maybe I'll just start from web development.